Stat routing protocol. So just a recap, routing protocol, we have the static and dynamic. In static, where admin has to put the entry, and dynamic, we need to enable the protocol. Like in the under this section, we have the RIP, IGRP, EI, GRP, OSPF, ISIS. This ISIS is not that ISIS. It's a protocol, not that ISIS. Right? So this thing we have discussed, and in the last class also we have done this. So if you come to the last class and if you see the diagram, we have made this diagram. So we had router, then we have one router here, and one more router here, and these are connected like this, right? This is, let's suppose this is R1, R2, R3, R. Here, let's suppose subnet is 192.168.1.0/24. Here 192.168.2.0/24, 192.168.3.0/24, right? So for this, we have discussed, right? If you want to go to this 3.0, then over the R2, we need to put the static route. In the reverse direction as well, if you want to go to the 1.0, we have to put the static route on R3, because by default directly connected interface will come into the routing table, right? So routing protocol, we have the two kinds of routing protocol, static and dynamic, right? Either we can use the static routing protocol, or we can use the dynamic routing protocol. Over that, we have the multiple routing protocol, right? So what I'm going to do, if I talk about this routing table, discuss about the R1. If I talk about the R1 routing table, R1. So here I will have the entry C. C means connected. 192.168.1.2 gigabit 0/0. Let's suppose 0/0, 0/1, gigabit 0/1, and gigabit 0/0. Here I have the IP address 1.2.1.2.1. Right? So this is the entry for this interface 0/0, and similarly we will get the C 192.168.2.1 gigabit 0/1. From R3 point of view, we'll get the entry in the routing table. C connected. What is the connected network here? 192.168.2.2 gig 0/1. C 192.168 3.1 gig 0/0. Right? This is the entry we'll get. Now, when you have the communication, when you want to have a communication from R1 to R2, when a packet comes to the R1 R2 router, it will look up for the routing table. In the routing table, it will not have the entry for 3.0, then it will simply drop the packet. At the layer 3, if router doesn't have the information to reach to the destination, router will simply drop the packet. But at the layer 2, if destination MAC address is unknown, then router PC sender are broadcast to get the destination MAC address. So in the static, in the routing table R2 and R3, we have the multiple ways to put the static entry. Yeah. We have multiple ways to put the routing table. Then we can use the static, right? So if I use the static, then S means static 192.168.1.0/24 via this interface 1.2.1, right? Similarly, if I talk about this, here S connect static 192.168.3.0/24 via 2.2. If you want to go 3.0, you need to put a packet on the R3 interface 2/2. If you want to go from this R4, if you want to go to 1.0 subnet, right? If you want to go from here, right? So for this router, the next stop is 1.1. This is right, 1.1 here. Sorry, 2.1. 2.1. Here is the IP address 2.1, right? From this router point of view, the gateway is this guy, the 2.2. So this entry we have to make into the routing table. This is the static approach. And if you run the dynamic routing protocol, let's suppose RIP. If you are running RIP, R means RIP routing protocol. What is the destination? 192.168.3.0/24 120/1 via 2.2. Here also we'll have the RIP entry 192.168.1.0/24 120/1 via 2.1. If you run the OS2 protocol, for OS2 protocol O, okay, just try to understand this RIP, what is the RIP, what is the O, what is the 128, what is the 1, what is the 120, what is the 1, this will come later over, right? This is what we are going to discuss. So if I talk about the O here, so 192.168.1.0/24, then 110/1, let's suppose 1, cost is 1, then via 2.1. Here also on this router, you will have an entry for O 192.168.3.0/24 110/1 via 2.2. I have the static entry, I have the RIP entry, I have the OSF entry. I can put other as well. I can put the EIGRP, I can put the RIP already there. I can put the EIGRP, I can put the OSPF, I can also put the BGP. So I can put it, no problem. But what is the problem with that? Let's consider the practical example. From here, if you want to go to the 40, if you have 3 ways, at the outside you have one sport car, one bicycle, one normal car, one is metro, one is bus as well. But at the end of the day, these vehicles, what they are doing, they will help you to reach to the destination. So if you have multiple options, you will choose only one. I have the cycle, I have the motorcycle, I have the bus, I have the metro, I have the sport car. Out of that, you will select only one, right? So similarly, these are the routing protocol. We have the multiple routing protocol, but out of that, we use only one protocol. What if we use all the protocols? Can you do that? At the same time, can you go to the bus? Can you go to the metro? Can you go to the bicycle and can you go to the motorcycle? Not possible. Cannot go. You have to select one protocol. You have to forget one protocol. You have to select one mode of the transport. From my point of view, I can select the metro. From other point of view, you can go for the sport car. Right? So If you run multiple protocol, if you run a single protocol, at the end of the day, you will reach to the destination because that is the main motive of the routing protocol. Routing protocol that learns that there are three functions of the routing protocol. The routing protocol, the main function is that to learn to reach to the destination, all the network. So I have the four vehicle. Now I have the, let's suppose I have the four path. I can from here I can go via Kukatpalli, I can directly go via Banjara Hill, or I can go via High Tech City. And let's suppose one more way like I can go via some area. So I have the four path and I have the four vehicle. Out of that, I need to select one best vehicle and best path from which path where I have the less traffic and definitely no toll tax. So these are the criteria, right? So to select the best path, the first criteria from the real point of view, I don't have the traffic. No, I don't want a red light. I don't want a toll tax. I don't want any kind of disturbance. If I start my vehicle, I don't have to put a brake on that. This is what we think when you start from the home, right? Even I also think, but it is not okay. The moment I come on the main road, right? Start. So now let's suppose I have the one two-wheeler and four-wheeler. Then I need to select which one I need to follow, which one I need to take, two-wheeler or four-wheeler, right? So same thing applied to the routing protocol. We have the routing protocol. Another thing is, let's come. Let's suppose in that area we have the multiple people and all the people are having two or three vehicles. What will happen if all the people start going to all the vehicles? Immediately, let's suppose immediately all the vehicles came on the road. What is going to happen? Traffic, delay, congestion. Same thing happen here. If you run a multiple protocol, if you run static routing protocol, if you run deep routing protocol, if you run OSP protocol, at the end of the day, the main function of the routing protocol to help you to reach the destination. But if you run the multiple protocol, your router will go down. You are running a multiple protocol. CPU utilization. For the same destination, router is processing three times. One is from static, one is from OSPF, and one is from read. No use of the running routing protocol, right? So there are some advantage when you run the multiple routing protocol, like when you come out of your home with the multiple vehicle on the road, you will get the congestion, you will get the traffic and delay to reach to the destination. You are supposed to reach in 1 hour in Hyderabad, but if you have the lakhs of the road, lakhs of the vehicle on the road, will you reach to this Hyderabad in 1 hour? Not possible. So same thing happened with the router. So the main motive, main function is to be main function. Our main motive is to reach to Secunderabad, right? But if you have this kind of facility where sports car, metro buses, right? I can choose one. If I put all the vehicle on the road, definitely congestion. So there are some advantage, sorry, disadvantage when we run the multiple routing protocol. So if I talk about the protocol, so we have the static and dynamic routing protocol. In our case, we are running three routing protocol: static, static, and these are the dynamic routing protocol. If you run this protocol at the same time on the router, what is going to happen? First is memory utilization. Which memory? Router. Second is CPU utilization. It will process, it will take more CPU to process the packet. Frame or packet forwarding delay. You are supposed to go in 1 hour to Secunderabad, but due to the huge traffic and the traffic comes because came because of the huge vehicle, because of the huge protocol. So definitely it will take more time to reach to the destination, right? Fourth is ease of management. So let's consider the police, the traffic police. You are a network admin. Instead of the traffic police, you are there with your traffic police signals, and but you are a network engineer. So it is also for him also it's very tough to manage, right? For you also it's very tough to manage, right? That is what the ease of management. Management will be very tough to manage those things. Lifetime of the router will get reduced. Lifetime will get reduced, right? So these are the advantage, sorry, disadvantage when we run the multiple routing protocol to reach to the destination. Because at the end of the day, the main function of the routing protocol is to reach to the destination, right? Now, if I ask you to do the selection, if I have the cycle, if I have the sport car, if I have the bus, if I have the metro, and if I'm asking to do the selection, which one will you prefer? According to you, some people will prefer the metro, some people will prefer the sport car because with the sport car you will get the luxury feel, good AC. Metro also you get the good AC. But with the help of metro, you will get the AC and you will get the less time. But if you go with the sport car, okay, that's fine. Internally you are cool, but outside is not cool, right? Anyone can come and hit you. But he will think about that. He will think before hitting you because that is a sport car, right? You never know who is sitting inside there. So these are the problem, right? So we have to do the selection, right? So in the same way, router also select the best routing protocol. There are some criteria. For us, the criteria is the car must be AC, right? And it should take less time. Router also consider those things. So let's static, right? Static will come later. First of all, let's discuss the OSPF and RIP. So if a single router is running multiple routing protocol, RIP, OSPF, EIGRP, multiple routing protocol, so they do the selection. In that, they do the selection of the routing protocol. So that depends on the AD value. AD value. From our point of view, what we select, we have to have the luxury line, we have to have the good metro, we have to have the AC. But the router, the selection of the routing protocol depends on the AD value. Selection of best routing protocol is on the basis of administrative distance when we run the multiple routing protocol. When we run multiple routing protocol on a single router, if we are running a multiple routing protocol like RIP, OSPF, static, so selection goes on the administrative distance, AD value. It means for every routing protocol we have the AD value, and lower is always preferred. So the range for AD value is 0 to 255. The 0 is most trust. 255 is not at all trusty. Not at all trusty. I would not trust on the AD value 255. Right? Then the question here is, okay, that's fine. We have the range. What about the AD value for the protocol? Right? So write down the AD value for protocol. So for the connected, first is connected. AD value protocol. For connected interface, AD value is 0. For the static route, AD value is 1. For RIP, AD value is 120. For OSPF, AD value is 110. For EIGRP, the AD value is 90. For BGP, okay, write down that ISIS as well. ISIS, the AD value is 115. And for BGP, okay, BGP actually in the BGP there are two kind of neighborship. BGP, the one is 20, another is 200. This is for eBGP, this is for IBGP. So right now you can skip this thing. When we discuss the BGP, right, at that time I will let you know what is the IBGP and eBGP. So write down this AD value, protocol AD value. For the connected interface, the AD value is 0. Static route, when you put the static route, AD value is 1. RIP routing protocol, AD value is 120, OSPF 110, EIGRP 90, and ISIS protocol 115. So, then if you come to the here, if you come here for RIP routing protocol 120, for OSPF 110. So that we know that this is the AD value. But what about this? So in each routing protocol, when we enable the routing protocol, static routing protocol or dynamic routing protocol, that comes as a AD value and slash notation. After that, we have a value. That value is called matrix. Not matrix, not the matrix module, matrix. I mean, we are. I think for each routing protocol, dynamic routing protocol, we have the AD value, and the range is from 0 to 255. So 255 is not at all trusty. If you don't 255, we'll do on lab actually where I will put the 255 AD value and it won't come into the output. And it starts from 0. 0 is the AD value for connected route, connected interface. And lower is always better. Remember, lower is always better. So if I have the AD value less compared to the other, so the less AD value, the routing protocol with the less AD value will be preferred over the routing protocol with the higher AD value. Let's do something. One side I am running OSPF and BGP, not BGP. Let's forget about the BGP. I am running on the router. If this is the router, on this router I am running OSPF and EIGRP. Which one will be preferred? Small AD value. EIGRP is preferred because EIGRP has the level lower AD value. If I am running OSPF and RIP, which one will be preferred?